best one, but I haven't tried that concept at all. I think that's pretty well it. How are we doing for time there?
It's 7:15.
I've still got some time left there. So let's go back to the beginning.
Beginning?
Yeah.
Okay.
I wanted to make sure we talked about the factors associated with radiation, because if you don't understand them, it's hard to understand, you know, the way you try to control them. That one there's one that you remembered.
Oh, and the Ariba.
Yeah, this is a system we did up at McLean Lake for Riva Resources. What was that, 50,000 square foot building, I guess, wasn't it?
140 living units and common areas and laundries and so on.
Yeah, yeah. And it's kind of an interesting story. This is the mechanical room, and we ran it with heat pumps running off lake water. And the lake water up there in the wintertime is not very warm, but anyway, there was a fair bit of negotiation went on talking about the capacity that we needed to heat this building. And I had said at one point that I needed 10 BTUs per square foot. And there was a big laugh. There was some talk of 40 BTUs per square foot. But the interesting thing about it was we put this all together, and in the first full winter of operation, it was monitored very carefully, and it was 7.5 BTUs per square foot. The total energy load was 8.6 BTUs per square foot, and that included all the domestic water, makeup air, laundromats, hot water, washers, dryers, and the whole bit. And McLean Lake, I think, is at the 59th parallel, isn't it? 58th parallel, 59th.
Close to the top end of Saskatchewan.
Yeah, yeah. The transfer mediums, of course, there's convection, conduction, and radiation. And here again, we get into a situation where, you know, you go on the computer and you look at this information. Now, if you look at a standard R20 wall or a fiber wall system, radiation goes through an R20 wall, so it's not even there. So we have never really concentrated on trying to save the radiation loss. And that's where reflective barriers come in, and it's a reflective barrier will reflect 97% of a radiation loss. That's one of the reasons why radiation heating is as efficient as it is. The R factor rating, I've got some real problems with R factor because that was one of the issues we dealt with in this log building. You know, when I talked about using logs for northern housing, everybody said, oh, it doesn't have a high enough R factor. And I said, well, I don't care what the R factor is, it'll consume less energy. And that was correct, it didn't. It did consume less energy, log buildings. The R factor test is what they call a hot box. And it works on fixed differentials, 50 to 70 degrees Fahrenheit for heating, and 70 to 90 degrees for cooling. And of course the other interesting thing is that the hot box is in an oven dry condition. Well, there's nowhere in the world that you can build a house in an oven dry condition. And 1.5% moisture content, by the way, in fiber reduces energy input by 35%, or it reduces the efficiency by 35%. Anyway, we'll go on to this is the electromagnetic spectrum, and that therein contains all the radiation. And we have radiation from cosmic rays, solar energy, and then you've got gamma, which is usually associated with the nuclear industry, and X-rays, medical, and the instant or the thermal range is the infrared and part of the ultraviolet. That's the only part of the electromagnetic spectrum that you can measure with a thermometer. Every test we do in North America is based on temperatures. So microwave, for example, there's no temperature associated with microwave. So we don't measure, the only part we measure of radiation is the thermal range. And that's why we have determined that there's some pretty serious weaknesses in the way we measure thermal gradients and thermal efficiencies. I was observer in a test that was done at Montana State University in Bozeman. We did quite a few projects down there, but anyway, it was at the time when closed cell insulation, fiber insulation, was coming on the market, and of course there was the big feud between the fiber people and the foam people. And in any event, they did an R factor, code R factor test. And then they had another wall section, which was the foam section. So they lowered the temperatures until they had an equal heat loss, and that turned out to be about freezing point. And then they lowered the temperatures down to minus 40 degrees, and it was 4 times the heat loss off the fiber wall as it was off the foam wall. Now and logs, to a great degree, are the same thing because it's a closed cell insulator. And as it gets colder, the resistance to heat transfer increases because the cells shrink and are less dense, and consequently there isn't the same heat transfer through them. Like a log building, for an example. If you look, and this is what the argument was when we were talking about using log buildings, didn't have a high enough R factor. But if you talk to somebody in Finland about R factor on log houses, they'll tell you that they're as good as anything you can buy. And that's the reason, is because they... Okay, we'll go to another one.
Oh,
That's not where we were, so we can go down further. Yeah. Yeah, we kind of talked about that too, so. Yeah, the R factor deals only with convection heat or forced air heating. It doesn't deal with radiation at all. There's little or no component of radiation that is, okay, that's fine. And now we get into another issue here, talking about a bit about thermal envelopes. And the ICF building is one of the most energy efficient envelopes money can buy. And I've had lots of discussions with the authorities about this. And Sunbridge Group, I was asking one of the senior people there one day, I said, what do you allow for, what's your allowance, thermal-wise, thermal losses for an ICF building? Well, he was sort of hesitant about it, but he said, well, an R28. I said, well, that's kind of strange because you got 3 inches of styrofoam, that's an R15. And if you got 10 inches of concrete, that's an R1, so that's an R16. How do you get to the R28? Well, it's through some tests they had done. But the fact is, it shouldn't be measured by R factor. What happens in an ICF building is radiation is absorbed in the concrete. It goes through the styrofoam with no problem at all, but it gets absorbed in the concrete and it becomes a heat barrier. If you can maintain 65 Fahrenheit or 16 C in a wall, you don't need any heating or cooling. And we have some systems now that we're working on where we're storing energy in the walls of an ICF building. But an ICF building is super, super efficient. Lots of people are building ICF basements, but they stop at the basement, and technically you should go the whole route with it. Now we have a thermal imaging camera, and I went out one night a couple of years back when it was, I think, minus 28 degrees out. And these are 4 different houses. That is an R2000 house. And any light color or any yellow, red, or light color like that means heat loss. Because all the thermal imaging camera measures is infrared. The house next door is an ICF house. And the ICF house has forced air heating, because you can see all the bosses up on the ceiling and up along the roof. So I know it's got forced air heating in it. If it had radiation heating in it, you wouldn't see any of those, because radiation inverse stratifies. These two houses up here are houses that were built in the 30s, and this is one that we converted using foil reflective barriers. And this is an identical house right next door to it. It's been converted now too. It's the same guy owns both of them. But we had done this one, and there's fiber insulation in it, of course, but that strip up the wall is a partition inside the house where we couldn't get foil behind it. So, and that's the old original house. It was still the same way. As a matter of fact, it's better than the R2000 house is. So, there's lots of room for improvement, and we tend not to be very aggressive when it comes to building good houses and, concentrating more on the thermal envelope and really putting together. So, now we've got some time for questions and...
Yes, we do.
Sure, okay.
It's really interesting. I was taught by Dumont, so of course I understand the R value. So what would you use for insulation? You would use like a foil?
Well, there's nothing wrong with fiber, because all fiber does is stop convection currents.
Mm-hmm.
Like if you look at a standard stud wall, I mean, the cold obviously falls down the outer wall and rises on the inner wall, and fiber slows it down. So there's a legitimate value in that, there's no question about that. But we've done a house with 2x4 construction, not 2x6. A 2x4 with a reflective barrier, reflective vapor barrier, and then 2x2 horizontal spacer that you can use for running